Okay, let's go ahead and get started for today. One quick thing that for the majority of the semester, the lectures will be in class face-to-face. The reason we are doing this remotely is I had despite being fully vaccinated, had a breakthrough COVID infection. And so I was sick for a few days. I'm doing much better now, but I don't know if you can tell, but I still have some sinusy things going on. And so I'm not, while I am cleared to return to class and teach face to face, I figured out of an abundance of caution and to make it so that uh, it's a little bit easier on me as I'm finishing up my recovery. I decided to just do the lecture videos for the first class. It might be the first two classes, but very quickly we'll be back to face normal activities. So for right now, there'll be several videos to watch. They'll be linked to from the course page where these lecture slides will show up. But on this page that you see here that you're looking at, there'll be links to the three videos. So the first part of the video will be a little introduction to the class. We'll go over the course syllabus. And actually, let's just go and start going through the presentation here and dig right in so we don't waste time. All right, so here's what we're going to do today. We're going to talk about the syllabus and course expectations. I'm going to talk a little bit about my teaching philosophy. And then we're going to dig into some stuff related to what systems programming is. So let's go ahead and get started with that. So first off, course expectations. Let's look at the syllabus. Give me a second to pull that up, and then we will dig into that. Now, the syllabus for this class is posted on the course page, so if you ever forget any of this, want to read over that, print out a copy, look at it at a later time, feel free to go back to the course page and look that up. But let me switch the window over so you guys can follow along here. So give me just a second and I will switch the window over. So let's go to that. Okay, so looking at the course syllabus, this is 2110 systems programming. And this syllabus is for section 1. The syllabus for section 51, the evening section is the same. The only difference is the times here, but everything else is the same. So just note that if you're in the evening section, your syllabus will say 5 to 7:15 rather than 2 to 4, and the location will be a different location as well. But other than that, the syllabus is going to look the same. First off, some of you have not had me for classes before. My name is Paul Yost. When you refer to me in class, you can refer to me in an informal way as just Paul. Hey, Paul, I need help with this. Hey, Paul, I have a question. There's no need for a lot of formalities. If you need to come to office hours, they are listed here. They're also posted on my door to my office. But Tuesday and Thursday, 1:30 to 2. So a half hour immediately preceding section 1. And then Monday through Thursday, 4:15 to 5. So following section 1 before section 51. So since that office hours adjoin your class periods like that, it should be relatively easy to get a hold of me by either coming in a little early, staying a little bit late, depending on which section you're in. All right, and my office is in 307 in the ATC building. So all the way up on the 3rd floor, get off the elevator, turn left again, walk around the back there. You'll see the my office there. All right, if you have questions or need anything, email me. pyost@shawnee.edu is my email address, or you can email me at my Gmail address if you need to. A note about office hours, they will be face-to-face during the times listed up here. And I can also be available other times by appointment. So for example, if you can't make office hours because you have a class that overlaps or something like that, or you feel like you need a larger block of time to ask things, feel free to contact me. We'll set up an appointment. We can set up a Zoom call if you need to. So a Zoom meeting. If you do come into my office, make sure to bring a mask when you visit face-to-face. There is no textbook for the class, but there are some books that could be useful. So if you're struggling or you feel like you would learn better if you had a book to browse through, let me know. I can give you the names of the authors and the books, give you a few references that you can buy, and then have those in your library that will help with the material. Course description, let's skip over that for right now. We'll come back to that in a second. But moving on to attendance, there is no attendance policy. So, but I do expect you to come to class. I'm not going to take attendance except other than what's required by the university. But you will be expected to learn the material. You don't get points for showing up. You get points for learning and demonstrating that you've learned the material for the class, and you get points for doing the work. Which brings us to the grading system. The majority of the points are for homeworks and homework programs that you write and turn in, any programming projects we have, quizzes that I give. That's the majority of the, or the largest percentage is in that category. 25% for the midterm, 35% for the final. One additional note there, you'll notice here in this section, it says that the final exam must be passed in order to receive a passing grade for the class. In other words, you have to get better than a 60%. So in other words, since I do round up, 59.5% or higher on the final exam to pass the class. If you get below that, it's an automatic failure of the class. And again, the final exam is kind of my way to make sure that you've learned the things that you need to learn, and you can be passed on from the class to do things in the next semester that rely upon what we learned here. Now, the good news is if you do your homework and know what's going on in the class and you have followed along and kept up with the assignments and gotten help when you needed it, getting that grade on the final will not be should not be overly difficult. All right, there's the grading scale that's listed. One thing to note, it says that the grading scale will be no worse than that, meaning I might curve grades or offset grades to help you, but I will never offset grades to hurt you. So for example, if everybody in the class winds up in the A region, everybody gets A's. But I may change the scale to help you. In other words, I may push the grades up or scale them up to give you a benefit. I'll never scale it down to your detriment. And again, notice the rule about the final exam there. A couple important rules. Don't cheat. In other words, I don't like intellectual dishonesty. If you're struggling and you need help, get help. Talk to people in the class. It's okay to discuss things in the class and how to go about that. That's how you learn. What I care about is that you learn the stuff, but don't just turn in somebody else's assignment, put your name on it. The stuff that you turn in should be your work. You should know like every line of code that you have submitted. You should understand it. Don't copy things from someplace on the internet that solves a similar problem or the same problem. Just turn it in as if it's your own. I want to make sure that you are learning the material for the class, so make sure what you turn in is your own work. And any instances of some sort of academic misconduct will be dealt with severely. So just don't do it. Other rule, don't be disruptive when we're in the face-to-face environment. We're there in class. In other words, you'll have freedom. It'll be kind of open discussion. We will be able to like talk, and you can raise your hand and ask questions, and we'll have some back and forth, and we can have fun in there. But just don't be disruptive. Don't play on your phone. Don't have outbursts that interrupt the class, except within reason. So in other words, treat it kind of like you would if you were in a movie theater or at a live performance for a play. Be polite, be respectful, behave professionally, turn off your cell phone. I know sometimes mistakes happen. Stuff gets left on. It's okay. I'm not going to like go off and if you accidentally leave your cell phone on, but just try to be cognizant that other people are in the class. They're paying to take the class. Don't play games in the middle of class. Surf the web, send and receive text messages, and so forth. Don't be distracting to other people that are paying to be there. All right, now, programming assignments will be posted to the course page. I'm sure at this point in your academic career, you know the drill. You'll turn them in, you'll complete them, you'll turn them in on there. And turned in means that you turn it in on the course page. If you're having some kind of problem with Blackboard and submitting things, let me know, and I'll give you an alternate way to turn things in. But don't send things to an email address and expect them to get graded without first talking to me about that. So you have to make prior arrangements if you need some alternate way to turn things in. All right, exams and quizzes. We'll have 2 exams, a midterm and a final. Those will be announced at least 1 week prior to being given. I won't give makeup tests unless you have discussed with me before missing the exam and have some excused absence reason for missing that. With quizzes, I might give those at any time in any class. So best way to make sure you get those, show up to class. And I will not necessarily announce the quizzes ahead of time. A lot of times in the lecture, I'll hint at, I'll say, oh, this would be a good thing to have a quiz on next class. Hint. So just be ready to take those quizzes. Those are given in class. And because of the nature of those, if you're not there to take them and I give them back the next class and go over them, I can't let you take a makeup quiz if you have missed that, not talked to me, and I've already graded them and given them back. Okay, ADA statement. If you have some sort of accessibility need, make sure to work through the Office of Accessibility Services. The phone number is included there for convenience. And also, they will notify me, but what I like to do is make sure that if you have some need and you feel like you need an accommodation for that, let's say for the midterm or for the final exam, make sure to let me know ahead of time, like about a week beforehand, at least the class before, so I can be prepared for that. I can get the exams to the Office of Accessibility Services or to the Student Success Center or wherever it is you're going to take that exam, or whatever you need. Make sure to give me time to do that. And a lot of students, even though they have some documented need for an accommodation, a lot of students, depends on the context, a lot of them will take the test normally. So the main thing I want you to know there is if you have an accommodation, we will work with you. But you need to work through that office and you need to let me know and communicate. So communicate those needs with me and I'll do everything I can to make sure that those accommodations are met. Then there's the Title IX statement down there. Essentially, if there's if you feel there's some sort of discrimination or harassment or of some sort that you have witnessed or has happened to you, make sure to let somebody know. See something, say something. And as a faculty member, it's important for me to have my classes and the students that are in my classes feel safe, feel like they're in an environment where they are free from any kind of negative things like that. So if you see something, you feel like somebody has overreached, let me know, or talk to the Title IX coordinator directly, and their phone number is included there as well for you to call and talk to them if you need to. Also, there's a way to report incidents on the Shawnee webpage. The URL is listed right down here. And if you feel like there's some problem, let me know, let the Title IX coordinator know, and we'll see what we can do to make sure that everybody has a safe and positive environment for this class or any class. Okay, so let's rewind now to the course description, since that's what we're going to talk about next. And this is a fairly long course description. I added some things to it. But let's read through this together. And then what we'll do is we'll dig into some actual material here today. So the course description says a computer requires software to be useful for something. In other words, a computer without software doesn't do anything. So you need software. So some software is application software, and some software is at a lower level than the application level. Systems programming is the activity of programming this lower level software for a computer system. The primary distinguishing characteristic of systems programming when compared to application programming is that application programming aims to produce software which provides a service directly to the user, whereas systems programming aims to produce software and software platforms which provides a service to other software. Sit directly on top of some hardware platform, are performance constrained, or most commonly, some combination of those. So in other words, we're writing software that's a little bit lower level, more like you could consider it at the hardware level, the operating system level, something that needs to be really fast. Maybe it's a library that's used. That library needs to be high performance. Or we're writing something that sits directly on a microprocessor-based system in some way. So the idea here is that systems programming is something that is at a much lower level than just writing a program that does something. Now, systems programming requires a great degree of hardware awareness, and its goal is to achieve efficient use of available resources, either because the software itself is performance critical, like a video game, where stuff needs to be really fast, performant, or because even small efficiency improvements are directly related to improved experience for the user or monetary savings for the provider. In that case, that would be like an embedded system, like a little microcontroller-based system, like a product design that has a microprocessor in it. And finishing this up as such, for this class, we'll be using C language as the programming language. And the reason for that is C is a high-performance, mid-level language that was designed specifically for high-performance systems programming. C language is used heavily by software that must provide high performance. It is much faster, for example, than Java, Python, or C#. And toward the end of the class, we're also going to introduce C++, which is sort of a descendant from C that added object-oriented programming onto C, which is an imperative or procedural programming language. So C++ and C are really closely related. C++ you can think of as an extension of C for adding classes and objects and things like that. But by the end of the course, the goal is that you're going to be proficient with the C programming language, and you'll be able to understand and write non-trivial pieces of software at that systems level. So that's what we're going to be doing in this class. So let's switch back to the presentation for just a second here. Okay, so looking at the presentation, we looked at the syllabus. Before we go too much further, I want to mention my teaching philosophy. And my teaching philosophy is that verb phrase to teach doesn't make a whole lot of sense. And you might say, like, well, why would somebody who is a teacher by at least part of my profession, why would I say that to teach is kind of nonsensical? And the reason for that is that other verb phrases you would think of, like, for example, here's some little post-it notes. I can do things like toss them. I could do things like tear them. I could do things like bite it or eat one of the notes or whatever, or this little rubber coaster thing, I can stretch it. I can flop it back and forth. So, but you'll notice that in all of those cases, that verb is something that is an active entity, me, doing that verb phrase to that object. And the object has no choice in it. If I decide to rip this post-it note, it's going to get ripped. If I decide to stretch this coaster, it's going to get stretched. But if I decide to teach you, I can't really do that in a kind of unilateral way without you learning. So in other words, it puts the emphasis on the wrong thing. I can't just walk into the class and like teach the hell out of everybody and then they leave there knowing stuff without you as a student being open to that teaching. So my job as a teacher is to be like a Sherpa or your guide. So let's say we're climbing a mountain. I know the way up the mountain. I know a lot of different routes. I know a lot of ways to help people get up there. But my job is to make it as easy as possible for you to get to the top of that mountain. My job is to be like one of the wizard professors at Hogwarts that you're there to learn to do magical things. I know how to do those things and how to mentor you and help you learn those things. My job is to make it as easy as possible for you to learn. Your job is to be active and make sure that you are doing your part in being active and learning things in a way that is best suited to you. So in other words, if you're struggling, come to my office hours. If you need help, send me an email and ask for help. If you have questions and we're in class, raise your hand, ask those questions. If you it still doesn't make sense, then we'll see if we can get an SI or a tutor to help you. Maybe you can have study groups or whatever, talk to other people in the class. In other words, it's going to be up to you to take an active role in understanding and making sure you're on top of things. Do the assignments, do the work, make sure that you are ready and prepared for putting some effort in. And even if you've programmed before in other programming languages, C language is going to be different for you. If you haven't programmed in it before, even if you have, a lot of people that have programmed in C before. In fact, I know people that program with C all the time, and it's part of their profession, and they still don't know how it works. They're still they have a lot of misunderstandings about it. Now, I have programmed in C language for years. Professionally, I know C pretty well. It's actually a really beautiful language, as we'll see later on, but it's going to be a little bit different than if you are coming from a place of only having used Java or only having used Python. There's going to be some lower level things going on in it, some stuff that's going to be a little more lower level is the best phrase I can use for it. Something that's going to seem a little more tedious, but you're also going to have much more control. There's also going to seem like some things that are dangerous in C, but we're going to talk about those and learn those pitfalls as we go through, because it gives you great power over the machine, but you got to be a little bit careful with how you use that power, because it's designed to be a systems programming language. It's not going to idiot check you. Okay, now, systems programming is a type of computer programming. But what makes it different is it's at a lower level, which means that we need a language that allows us to directly control the hardware of the computer. And that means that it requires a different kind of programming language. So for example, a language like Python or Java, you don't have a lot of control over exactly what's going on in the processor or in memory. Those languages are not suitable for systems programming. Python's a great language. It's not suitable for systems programming. Java is a good language, not suitable for systems programming. It doesn't give you the low-level direct control over the hardware and what's going on in the CPU and what's going on in memory that you need to do systems programming. So we're going to use, that's why we're using C language, and the tools, the compiler tools we're going to use are going to be a little bit different as well. All right, since we're going to be programming at that lower level, we're going to talk about how the computer works at that lower level. And this might be something some of you have seen before in other classes or talked about before in other classes. Bear with me through this if you have. If you haven't, then this will be something that's new to you. But it's also something that's going to be very powerful. So with that said, we're going to leave this presentation and we're going to switch to how the computer works. That will be done with a separate recording. There are two of them, Part B and Part C. I divided it up to try to make it easier for you to watch those in two different chunks. So go ahead and watch those two. You can click these links here in the presentation, or you could just type those things in and get to the videos. But if you go to the course page, you just click on the links. I'll also copy them onto the front page so you can just watch Part A, which is what this is, and then Part B, and then Part C. Just make sure to watch those. And everything should be good. That's all we're going to do today is this presentation, the syllabus stuff, and then Part B of how the computer works, Part C for how the computer works. So make sure to watch those. And then as far as the next class, the class for Thursday, I don't know if that will be in person or via video. Keep an eye out for the email. I'll send out an email to you. It'll show up in your university email that says whether the class on Thursday will be also on video or not. If you don't get an email, just assume that it is in person and come to class. It depends on my symptoms. I'm cleared to go back to teaching face-to-face, but since I still have some symptoms, mostly sinus symptoms, I just decided to err on the side of caution and stay away until A, I'm feeling a little bit better, and B, it's very clear that I'm no longer symptomatic. So Thursday might be another lecture video, but might also be in person. Just keep an eye out for that. And that's all we're doing today. Make sure to go back and watch these videos. And I will stop the recording here. For this part, which is part A, watch part B, watch part C. There may even be a quiz on Thursday. There's one of those hints I was talking about. But what we're going to do next class is, after you watch these two videos, we're going to go a little bit further with that how the computer works presentation. And we're going to start digging into some lower level kinds of stuff. And then next week, we're going to really dig into the C language and start going through a list of subjects with that. And you're going to have some labs to do. Also note that there is an assignment. It's really simple. All you have to do is download that off the course page, fill out the stuff, submit the document back to me, the PDF file back. And that's just an assignment so you get used to the Blackboard system and submitting things, but also it's a way for me to get to know you a little better, even though we're not in class together for this first class. All right, so that's it. So I'll see everybody hopefully on Thursday. Make sure to watch those other two videos. Bye.